Hi everyone, I hope you can hear me. Can you quickly confirm? Can you please let me know if everything is fine? Audio, video, everything is fine? Okay. So, hi Vijay. Hello Rohit. Hi Lalit. Hi Kundan. Hello Subhadeep. Hi Aru. So, I hope things are fine, right? Okay. Hello Maverick. Cool. Let's get started. So today, as you know, that we are going to start with probability random variables. So mostly I will be just focusing on the distributions, which means like I will be just focusing on the random variable and associated distribution, which are like uniform distribution, Poisson distribution, exponential distribution, like that, right? Okay. And before I start, let me quickly introduce myself. I'm Sachin. I finished my master's from Indian Institute of Science, and after ISC, I have worked at various companies, including Amazon. At Amazon, I was working as an applied scientist, and I have also achieved GATE All India Rank 33. So, like most of you might be knowing me because you are on this channel. But like in case if you are not aware, then this is my profile. Okay. So I hope now we can start, right? Let me know if there is anything you want me to discuss before I actually start the topic. Okay, cool. So let's just continue. Now, my first question before I continue is that what is a probability? What do you think is a probability? So, for example, suppose if I say that probability of appearing, let me just a second. So, give me a second. Yeah. So, suppose if I say that probability of appearing head on toss of fair coin is 1 by 2, then what does this mean? Which means if I'm saying that the probability is 1 by 2, if I just toss it out, then what does this mean of saying that probability is 1 by 2? Does this mean that, okay, Rohit is asking some doubt that I am doubtful about this year gate. Should I drop or take one more drop? Should I drop and prepare for one more time? I'm last year passed out. Rohit, what you can do, you can just wait for some time. I will answer your question. I will definitely answer. You just wait for some time. I will answer this in a great way. Okay. And once the session finished, you can just drop me a message again. Right? Okay. Now, if I'm saying that probability of appearing head on the toss of fair coin is 1 by 2, then what does this mean? Am I saying that if you toss two times, then you will definitely be getting one head? Am I saying something like this? Let me know. So if you toss two times, then will you definitely be getting one head? Is this true if the probability of the head is 1 by 2? Okay. Just let me know what do you think about this. See, if you're getting like if you're sure, then I think things are not probabilistic. If you're sure, right? So there must be something that you're missing. Let me know. Like, what do you think about this statement? Uh, just a second. Let me just adjust my screen so that it is clear to everyone. Okay. So what is your answer? That on average. Okay. On average, your answer. Yes, we have Suresh coming. Okay. So basically, your answer is on average. What does this mean to say on average? See, if I'm saying that probability is 1 by 2, then I'm not saying that you will get one head out of two, out of two. This is not what I'm saying. Or similarly, I'm not saying this. Similarly, I'm not saying that you will get two heads out of 4. Am I saying this? Am I saying this if I'm saying the probability is 1 by 2? No, I'm not saying that also. Am I saying that you will be getting 4 heads out of 8 tosses? Am I saying something like this? That you will be getting 4 heads out of 8 tosses? No, right? So neither I am saying that nor I am saying this. Then what does this mean to say that probability is 1 by 2? What does this mean to say the probability is 1 by 2? If I am not saying none of this, if I am not saying this, neither I am saying this, neither I am saying this, then what does this mean to say that probability of head is 1 by 2? It means that if you toss enough number of times, okay, if you toss enough number of times, then half of the time you will be getting head, half of the time you will be getting tail. So that's what I'm saying, right? So basically, whenever I'm defining the probability, it means that I am saying that if you do it enough times, okay, if you do it enough times, then only we are talking about it. Otherwise, it does not make much sense. I hope that is fine to everyone. So probability doesn't guarantee you something, but it just says that if you do it enough number of times, then you will be getting like out of X times you do, you will be getting half of the time head and half of the time tail, right? This is what I'm saying. Cool. So basically, let me give you some example that if you toss okay, sorry, actually I'm not feeling good today, so that's why I'm not that much energetic, but I will prove these things. Like I will teach in the random variable in such a way that you will never forget it. That's my promise, but my energy is not coming out that I wanted to put in this particular lecture. Anyway, I think it is a wise idea that I keep my voice low and then I distribute this lecture. Okay, let me just continue. So what I'm saying here is that you will not be getting head or tail one time after of 2 times, or maybe maybe 2 times or 4 times, something like that. But if you do it enough number of times, then you will be getting. For example, if you toss a fair coin 4 times, then the outcome may not be 2 heads and 2 tails. That's for sure. However, if you toss same coin maybe enough number of times, to 4,000 times, then the outcome will be close to half of the heads and close to half of the tails. Okay. So, for example, English statistician, this Carl Pearson, who tossed a coin, he actually tossed a coin 24,000 times with a result of almost 12,000 times head and almost rest of the time tails. Similarly, one of the author tossed 2,000 times, then result was 996 times over head. So probability tell you that how likely an event is to occur. So I hope you are getting my point. Right? So basically, probability tells you that how likely it is going to occur out of X number of experiments. So basically, like now you may ask the question that what do you mean by enough number of times, right? Enough number of times. What do you mean by that? Which means if I say that probability, let's suppose you are doing some gambling, okay? You are doing some gambling, and if I say that probability you win is actually maybe, let's suppose 1 by 3, okay, probability you win maybe, let's suppose a lottery, it is 1 by 3, or maybe let's suppose let me could not call it 1 by 3, let me call it even lesser. Let's say it is 1 by 10. Okay, probability that you win a lottery is 1 by 10. Probability you lose the lottery is basically 9 by 10, right? There are more probability that you will be losing the lottery. Suppose the gambling or something you are doing. Now, it doesn't say that if you draw the lottery tickets, let's suppose 10 times, then you will be winning one time. It doesn't say this. Okay, then it doesn't say that you will be winning one time. No, you may lose 10 times also. Basically, if the probability of head is 1 by 2, it doesn't mean that if you toss 2 times, there will be one head and one tail. No, it doesn't mean this. What does this mean? It means that if you do it on enough number of times, then you will be getting half of the time head, half of the time tail. What does this mean to say? Let's suppose you toss it and you get tail. You toss it again, 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 you get tail. Similarly, you keep on getting tails. Okay, suppose you keep on getting tails, which is, let's suppose these are the 10 times you got tails. 10 times. Let me know if that is possible or not. Even though the coin is fair, is this possible that you get 10 times tail in a row? Is this possible? Yes, Subhadeep. Actually, it was very hectic schedule for us. Let me know if it is possible that you will be getting 10 times tail. Definitely, it is possible. Mathematics doesn't say, right. Mathematics doesn't say that it is not possible, right? Mathematics doesn't say this. Mathematics may say that the probability is very less. What is the probability that you will be getting till 10 times? The probability might be very less, 1 upon 2 power 10, but it doesn't say it won't happen, right? It doesn't say this. Then what does this mean of saying that the probability of head is 1 by 2, even though you are getting tails, you toss it 10 times, you are getting tails? Then what's the point of this probability? See, this probability is not saying that out of 10 you will be getting 5 head or 5 tail, nothing like that, right? It is just saying that enough number of times you toss it, I guarantee it that you will be getting half of the time head and half of the time tail. And then you actually did it, right? I mean, you tossed it 10 times and then you came to me that whatever you were claiming about the probability and all of this is rubbish, because I actually tossed it enough number of times and I got 10 tails, even though the probability is 1 by 2. So whatever you are teaching is just rubbish, right? I mean, the probability is 1 by 2 and I tossed it 10 times, I'm getting the 10 tails. So I will just say, like, if you come to me with this idea that see, even though the probability is 1 by 2, I took the fair coin and still I am getting 10 tails. If you come to me with this idea, I will say that okay, maybe you have not tossed it enough number of times. You will say to me that see, no, I have tossed it enough number of times. 10 is enough, right? I mean, 10 is too big number. I will say it might be big for you. This 10 might be big for you, but it is not big for me. Maybe not for mathematics. You will say, okay, I will come to you again. Let me toss it 100 times. You actually tossed it 100 times. You found out that everything you are getting tail and just one head somewhere in between. You are just getting one head somewhere in between. Everything you are getting tail. Okay, so you tossed it 100 times. You came to me again, you said, see, you are a liar. You are again saying that you tossed it 100 times, you will be getting you will be getting 50% of the heads, 50% of the tails. But I tossed it even more than enough. I tossed it 100 times, still I'm not getting head enough, like 50% of the time. I will say, see, dude, you have not tossed it enough number of times. You will say, oh, come on, 100 is too big. I will say, no, it might be big for you. You should be tossing enough number of times. Then this time you really work hard and then you tossed it 500 times. You tossed it 500 times. Out of 500 times, maybe 2-3 times head occur and then all of the time tail occur. I will say that okay, mathematics can't deny it. I mean, the probability might be very less, like mathematics doesn't deny this sequence, the probability might be very less, that is for sure, but mathematics doesn't deny this sequence. I will say, see what you did. So you will tell me that see, this time I have tossed 500 times, it's still just 3 heads, it's still just 3 heads, right? This time you have tossed 500 times, still you are getting just 3 heads. Now okay, is my screen completely visible or there is some issue? Cool. So I think this is visible, right? Let me just see if there is some. Okay. So if you just come to me again and then you say that see, I have tossed this time also, I have tossed 100 like enough number of times, still I'm not getting whatever you are promising to me. I will say that see, this time how much time how long you have tossed it? You will say that I have tossed it 500 times. I will say it is also not enough, right? Okay, I will say it is also not enough. Then then probably you will say that see, 500 is too big number. Why it is not enough for you? Then I will say that okay, it might be too big for you, but it is not too big for me, right? It might not be too big for me. That's the issue. Then you actually work hard and you have tossed it maybe 10,000 times or 5,000 times, let's suppose, and most of the time you are still getting head. Let's suppose only 50 times you have got head, I mean most of the time you are getting tail, only 50 times you have got head. Then you will say that see, this time I have tossed 5,000 times, still I'm getting just 50 heads. How can you claim probability is 1 by 2? I will say, see, maybe you have not tossed it enough times. Then you will come to me again and then you say, see, dude, 5,000 is too big number. It is quite enough, right? Then I will say, maybe it is enough for you, it is not enough for mathematics. So what do I mean by that? Like how would I conclude it? I will say that this enough, whatever I'm saying enough, is actually just a theoretical number. You cannot say that okay, 2000 is enough, 5000 is enough. Okay, this is just a theoretical number. But practically, even if people did it, okay, practically people actually just tossed 4000 times, okay, 24000 times, people got 12000 times head. Similarly, someone actually tossed it 2000 times and he or she got 996 times heads. So practically it doesn't happen, to be honest. Okay, the probability is 1 by 2, it doesn't happen practically, but I'm just telling you that it may happen, but it doesn't mean the probability is lying to you. It is just that you might not have tossed it enough number of times. So suppose if you are playing a gambling and I say that okay, you win, the probability is 1 by 10, you lose, you lose the game, the probability is 9 by 10. Then it doesn't mean that I'm saying that out of 10 times you will be winning one time. Okay, it doesn't mean I'm saying that you will be winning one win. No, I'm not claiming it. Neither I'm claiming. See, if I'm saying that with this probability you are working, let's suppose, and if I'm saying that these are the probabilities, then I'm not claiming that out of 10 times you will be winning one time. Neither I'm claiming that out of 20 times you will be winning two times, something like that, right? I'm not claiming anything. I'm just saying that there's a chance that if you play enough number of times, then on an average, okay, on an average, out of 10 times you will be winning one time. Now you actually played the game, and let's suppose you played it maybe 100 times and you lost all of your money, and then you come to me that you are saying that I actually played 100 times, and out of 100 times I was expecting that I will be winning at least 10 times. If not 10, then at least one time I will be winning, right? So I will say that see, you might not have played enough number of times. See, you cannot come to me after this lecture. If you go and do the gambling, then you cannot come to me and say that see, whatever probability you are teaching to me, this was all rubbish because I just lost all of the things, all of the assets which I had, because I thought the probability of winning is 1 by 10, and I actually played the gambling 100 times and I lost all of the things and I'm not getting anything. So all of your theory is wrong. No, maybe I will just suggest you not just 100. Maybe I will just suggest you to do it maybe 5000 more times. I mean, I will not give you the number because otherwise you will claim me. I will just say that maybe you just played enough times. Okay, I will just say that maybe just play this gambling enough times. I will just say this to you, right? Okay, so I hope you understood what do I mean by that. So probability is telling you that probability is not claiming anything. It is just telling that on average what are the chances that you will be winning. Cool. Let me know if you have understood everything. Okay, so now let's just move further. Now, probability definition is clear. Mathematically, you can say mathematically probability is number of times uh, that event is happening, right? I mean, probability of that event, number of times that event is happening upon total number of times that you have actually done the experiment, where the n is actually going to infinity. I mean, mathematically there are some definitions of probability, but I don't want to deal with those definitions, right? I mean, the probability of event is something like this. Okay, where this thing is actually going to infinity, because you have to do it enough number of times. Okay, probability of event is actually something like this, right? I'm not telling you the exact definition because it is not required for gate, but I hope you understood that what do I mean by the probability. Okay, I only mean that you should be doing it enough number of times. Now you cannot ask me what is this number enough, because I also don't know, right? You should not come to me and then you should not ask me what is this enough, because these are just theoretical numbers, right? I mean, these are just theoretical ideas. Okay. So now let's talk about the sample space. In this lecture, I want to talk about the random variable, and the random variable is basically a function that I will tell you that why it is even called the variable and all. But before that, I need to talk about some basic definition so that you are more comfortable with these things, right? So what is a sample space? Let's just see what is a sample space. This is basically saying the set of all possible outcomes that can come out of the experiment. That is called sample space. What do I mean by that? Let's just see. Let's just see. See, you perform some experiment. What do I mean by the experiment? Experiment is anything. You toss a coin. This is an experiment, right? Tossing a coin is an experiment. Similarly, whatever you are doing is basically an experiment. Now, if you toss a coin, there could be two outcomes, either head or tail. So your experiment is tossing a coin, and outcomes are head and tail. Whatever the possible outcomes are here, you just write them out. Okay, write the all possible outcomes here, and then you will say that okay, whatever is the possible outcomes that you have is actually called the sample space. Got it? So this is called the sample space. Sample space is just a set of the set of all possible outcomes. Cool. So now you understood the sample space. Then maybe I can go to the definition of event. Then I will be just connecting the dots. So what is an event? Event is basically a subset of sample space, which means in earlier example, if I talk about an event, then I will say first of all, my sample space is head and tail, right? This is my sample space. If your experiment is tossing a coin, let me know if you are getting my points or there is some confusion till now. Okay, so I hope things are clear, right? So Aramika is asking, probability remains constant even in infinite experiment performing. What do you mean? What do you mean by that? Okay, so let me maybe address this question before I go further, because these are the basic questions, and if I do not address this, then maybe you will not understand the further part. So let's just address this question that what she is asking, right? So she is saying probability remains constant even in infinite experiment. Let's just understand this question very nicely. I mean, what does this even mean? Let's just understand. Suppose I say there are two things. Okay, there are two things that we will be talking about. Let's suppose I do not know the probability. There's two situations. That first is that I do not know the probability. Okay, which means I'm just performing the experiment, but I do not know the probability. So let's consider situation one where I do not know the probability. Okay, consider situation two. I know the probability. So I will come to the situation 2 in just a while. Okay, let me first come to this situation 1, but that suppose I do not know the probability. Suppose I have a coin. I do not know whether it is fair or it is not fair. I do not know what is the probability of head. Okay, suppose I do not know the probability. So what will I do? Can anyone tell me what will I do? And I want to know the probability. What will I do? Okay, so if I do not know the probability and I want to know the probability, right? And so I will just say that, see, I do not know the probability, but I want to know the probability. What can I do? I will just toss a coin, right? I will just toss a coin, isn't it? Let me know if that is okay. I toss it maybe maybe 10 times. I got head, 3 times head, 2 times tail, then maybe 4 times head, 4 3 7 8. Okay, 4 and 3 7 8 9, and then 1 time tail. Okay, let's suppose I toss it 10 times and I got this output. Then what will I say? What is the probability of head? What is the probability of head? I will say this is 7 by 10, isn't it? Looking at this data, I'm just finding out the probability. Let me know if that is clear to everyone. Looking at the data, I'm finding out the probability, which is coming out to be 7 by 10. Now, suppose I just toss it one more time. I just toss it one more time. I again found out that there is a head. I again found out there is a head. Now you will say that probability is actually 8 by 11, not 7 by 10, right? It is 8 by 11. I again again tossed out, and then I found that okay, that there is a tail. Then I will say that probability is actually not 8 by 11, it is 8 by 12, right? Out of 12 times, I'm getting 8 times head. Let me know if that is okay to everyone. So what I'm doing, I'm basically, these are called samples. These are called samples. Okay, I'm collecting the samples. I'm collecting the data point, and from this data, I'm trying to infer the probability, isn't it? From this data, I'm trying to infer the probability. I'm saying that okay, I got 7 times head. Out of the 10 times, maybe most probably the probability is 7 by 10. Then someone suggests you that why don't you toss one more time? You tossed it one more time, you got one more head. You will say, okay, okay, actually the most probably the probability is 8 by 11. Then someone says that, okay, why don't you toss one more time? If you toss one more time, then let's suppose you got 8 by 12. I mean, you got one more tail, right? Then you will say that, okay, sorry, my probability is not 8 by 11, the probability is 8 by 12, because I just got one more tail. Out of the 12 tosses, I got 8 heads. Then what will happen? What are you actually doing? You are collecting the data, and based on the data you are changing your probability, right? So you did not know the probability. See, initially to start with, you did not know the probability. That's the catch here. You did not know the probability, and then you are tossing, and then based on the data you are trying to infer the probability, right? So you don't know the probability, but you have the data. From this data, you are basically collecting, you are basically finding the probability, right? Finding the probability. So this is called uh, like the probability that you're finding from the sample, right? This is not a true probability. So how you will get the true probability? You will say that, okay, I wish I have more data. I wish I have more data. Why? Because the more data I have, right, more accurate I will be. If I have more data, then I will be more accurate. Which means, let's suppose you toss one time, you got head. Just by looking this data, what you will say? I tossed it one time. Out of one time, I got one head. Maybe the probability of head is one. Just by looking this data. Then someone suggests you that, oh, you fool, why don't you toss it one more time? Then you actually tossed it one more time. You got head again. You will say, see, I told you that the probability of head is actually one. That it every time this coin is so unwise. Every time it is telling me head. I just told you, right? Using just one sample, I told you, and you are asking me to do one more sample. I did it for you, and I am still getting the probability as one. Then someone says that, okay, you are again a fool. Why don't you toss it one more time? Then this time maybe you got a tail. Then you will say, oh, sorry, it is actually not 2 by 2, it is 2 by 3, and which is actually not 1, which means that this coin may show tail sometimes also, right? I mean, not just head. Then someone says that, okay, you are doing a rubbish thing. Why don't you toss it one more time? Then you toss it one more time. Then you found out that again you are getting tail. You will say, oh, sorry, out of 4 times I got 2 times head, which means the probability is most probably 1 by 2, right? So basically what you are doing here, based on the data, you are calculating the probability, and then you are again and again changing the probability, right? So basically, based on the data, you are calculating the probability, you are again and changing the probability, which is fine, which is completely fine, because you don't know the probability. Then that's the only best thing you can do. So here you will be saying that I wish I have more data. More data I have, more accurate I will be, because I will get to know the behavior of the coin more, right? If I have many data samples, then I will be actually predicting the probability with very much accurate. Now suppose someone says that, see, I have a trick, not a trick, I mean, like, I have a treasure for you, which means I don't just give you the 4 samples from which you are finding the probability. I will give you enough samples. Maybe I will give you 50,000 samples. 50,000, you just imagine, 50,000 tosses result I will give you, right? And then he said, okay, out of 50,000 that I have tossed, I found out maybe 25,000, okay, 25,000 10 times head was there. So you will say, oh, the probability of head is actually almost equal to 1 by 2, right? And that's what the people did. So what is happening here, that you are collecting more and more data, which means 50,000, you 50,000 samples you have collected, and from this 50,000 you are finding out the probability. So that's how the probability you are going to calculate. See, the thing here is that you don't know the probability, right? And then you are going to find the probability. And how you can find the probability? The more data you have, the more accurate you will be. Now you might definitely guess that that's why there are the companies which are hungry for your data, right? Because the more data they collect about you, the more accurately they can train their machine learning models. Why? Because the more accurately they can predict this probability, right? I mean, see, this was a very simple prediction, which is number of samples number of total experiments, how many times you are doing, a number of the favorable samples or whatever, right? Favorable samples. This was a very, very naive estimation that we were doing. But there are machine learning models which actually does the same thing, which means the whole of this machine learning is just finding out the probabilities, right? Like the whole of the machine learning is actually boiling down to just one thing, which is basically the predicting the probability. And the more data you have, more accurately you can predict the probability. So that's why more companies are just eyeing up on your data. That's why the more companies are looking for your data, because they want to train their machine learning models more accurately. They want to predict the probabilities more accurately, right? So that's was the situation one, where you do not have the probability, and then you wanted to know the probability, right? So here I said, like, you do not have the probability and you wanted to know the probability. Now let's consider situation two. Situation two is where you actually have the probability. Okay, now you are saying that I know the probability. So suppose if you are saying I know the probability, which means the probability of head is, let's suppose, whatever it is, does not matter, 1 by 3, 1 by 5, whatever it is, 1 by 2, but let's suppose you know the probability. Okay, this time you are actually claiming that you know the probability. Let me know if you are getting my point. Whatever I am trying to convey, let me know if you are getting. Okay, okay. So let's come to the next point, which is basically saying that you know the probability. If you know the probability, then actually, to be honest, it is not a practical scenario. I mean, we do not know the probability of a general behavior. So it means you are actually king. You are a king. You don't need data. You can actually generate the data. There are generative models. Okay, there are generative models in machine learning which generate the data, and how they do it, like, obviously, like, we do not need to worry about it, but somehow they say that they know the probability. They fake themselves that they know the probability. If you know the probability, you are king. Okay, you do not need anything else, or king or queen, whatever. In case of Anamika, she will be queen. Okay, so if you know the probability, you are king or queen. I hope now it is understood. So she was asking that probability remains constant even in infinite experiment. If you know the probability, it is remain constant, right? You know the probability. Now data can change your probability. Let's suppose you know the probability of head is 1 by 2. You tossed it 5 times or 10 times, or maybe let's suppose 4 times. Out of 4 times you got maybe just one time head. It doesn't mean the probability of head now becomes 1 by 4. No, it doesn't mean this. Your probability is 1 by 2. You just not have collected the enough sample, right? You are drawing the samples from this distribution, right? That is called drawing the samples from distribution. So why I'm telling you this, like, you might say that these are not relevant for gate, but actually these are relevant. Once you understand, once you have the feel for the probability, then you will actually get to understand that random variable very nicely, right? So just to build the plot, I'm telling you all of this. It might just take half an hour more, which I was planning, but I hope that is worth. Okay. So let's just continue. That now I hope you understood that what does it mean to say that you know the probability. If you know the probability, then this data तो छोटी मोटी बात है. मतलब डेटा को ड्रॉ करना तो मतलब छोटी बात है. Probability पता है is a bigger thing in itself. If you know the probability, you are a king or queen, right? Now you are drawing the samples. You may draw the samples where your probability and the drawing the samples are not matching. Then what will I say? See, you have not drawn enough number of times, right? You have not collected the enough sample. दो चार लोगों को बोल के दो चार लोगों को देख के थोड़ी बोल देंगे कि सब लोग अच्छे हैं, सब लोग बेकार हैं, राइट? लेट्स सपोज आई वांट टू नो व्हाट इज द probability. I pick a person, pick or choose a random person, pick a random person. It is a nice probability. Random person is nice. What is the probability random person is nice? Let's suppose the probability I know, okay? Suppose I know it is 1 by 2. I know it is 1 by 2. I know it. Now you say that, okay, let me just verify. Okay, you will say that let me verify. What you do? You just pick some samples. You go and picked 4 people. You picked 4 people, and these 4 people are extremely bad. Okay, or maybe one of them is nice only, or all of them are bad. Okay, all of them are bad people. You picked the bad people. Then you will come to me and will say, see, you were lying to me. The probability of being a nice is not 1 by 2. In fact, it is 0. It is 0. I picked 4 samples, and then I'm finding that none of them is nice. So the probability of picking a nice person is actually 0. I will say, see, you are just picking 4 people, एंड 4 लोगों के हिसाब से पूरी दुनिया को थोड़ी बोल देंगे कि सभी बेकार हैं, है ना, या फिर सभी अच्छे हैं, जो भी है उनके हिसाब से थोड़ी कंक्लूजन निकाल लेंगे. कंक्लूजन आपको निकालना है तो कलेक्ट एनफ सैंपल्स, isn't it? You should be collecting enough samples. Okay. Cool. I hope you understood my point. Now let's just move. So here I was talking about, there is an experiment, you do an experiment and then there are outcomes of experiment, maybe head, tail or something like this, right? Now what is an event? Event is basically a subset of experiment, which means if you're tossing a coin, then you might get head, you might get tail. So head and tail are called outcomes. Set of all outcomes is called sample space, and subset of the sample space, subset, okay, subset of the sample space is called event. Okay, so which means that if the sample space is head and tail, then what is an event? Event is subset, maybe head, maybe tail, right? What else? Maybe head, tail, both, right? This is also event. These are all examples, or nothing, right? I mean, like, don't worry about the probability. The probability of this nothing is happening is like this event happens is actually 0, right? Similarly, the probability head occurs or tail occurs, this probability is 1, this probability is 0, and these the probability 1/2. Okay, I mean, depending on the fair or bias, unbiased or biased count. But anyway, let's not worry about the probabilities. But these are the events that are possible here, right? Either head will occur, tail will occur, or you say there is some event which is saying actually head or tail, either of them can occur, and then the probability that nothing will occur is actually 0, right? Okay. So see this diagram. This diagram is actually summarizing all of these pictures. It is saying you perform an experiment. Okay, you perform some experiment, and then out of this experiment there will be some outcomes. These are the outcomes. You collected all possible outcomes. You call that as a sample space. Then you are saying that, see what I do. I hope you are getting right. So okay, let me remove this picture, later picture, and then you will understand it. Then I will come to this again. Okay, so basically, see, first step is that you perform the experiment, you get the outcome. You are saying this is the sample space, right? You will say that this is the sample space. Then in this sample space, you picked some subsets. You pick some subsets. You will say that these are the events, right? These are the events. Now you will talk about the probability, which will, you will say that, see, out of this I will define the probability, which will say that, okay, probability this event will occur is the basically the probability of B, probability this event will occur is probability of A. So these are the probabilities, right? Okay, let me know if there is any doubt till this point. Cool. I hope you understood, right? Okay. Now let's just take some example that what are the events and what are the not events. Let's suppose you toss two coins. Tell me what is the sample space? What is the sample space? Sample space is maybe head can occur, set of all outcomes, which means set of all outcomes. Right? Now, what is sample space? Head, tail, head, tail, and tail, head, right? So these are the sample space. This is the sample space. What is an event? All possible subsets of this. Let's suppose I denote my sample space by I think this is called omega, right? This symbol is omega. So suppose I denote it by small omega. This is called small omega. I denote it by this symbol. Let's suppose. And if I just ask you that if this is your sample space, then what are the events? You will say all possible subset of this. So what are the all possible subsets? How many subsets will be there? 2 power omega, right? For every person, you will say maybe it will come, it will not come. So 2 power omega is your number of events basically, right? Okay. So now for every event, let's suppose I say that HH is one event. Similarly, TT is one event, and similarly there are many other. HT comma TH is also one event, right? So then you will define your probability. You will say that, see, these are your events. Now let me just say the probability okay, the probability of some event, maybe HH. Now you will define a probability on top of the event. Probability is always defined for the event. Maybe there is some probability, I don't know, okay. What do you think is the probability? I think 1 by 4, right? Out of 4, you are saying this is possible, it is 1 by 4, right? So these are the probabilities that I have. Let me know if that is understood to everyone. Okay, cool. I hope that is fine to everyone. Now, what I'm trying to say here is that I'm just telling you this probability is basically a function which is defined upon an event, right? Now, obviously, I don't want to do it, but suppose I just for a second, if I define the probability as a function mathematically, then I will say that it is basically the domain, like it is mapping from something from 0 to 1, and what is there something event, and a set of all possible events, basically the set all possible events is 2 omega. So this is mathematical representation of probability, although you don't need to do it, right? Anyway, have you understood that probability is defined on the event? That's what I want to tell before I start the random variable. So today I just wanted to start the random variable, but before that I will just want to make sure that what is the probability? It is something which is defined on the event, nothing else. This is the proper definition of the probability. Then why I'm telling you this for the random variable? Because in the random variable I'm just going to write something like this: probability of x equal to 3. So you should be knowing what is this x equal to 3, because I'm saying the probability is defined on an event. Now you should be knowing that why I'm calling this thing as an event. What makes this thing as an event, right? So for that you should be knowing what is an event and all, because probability is defined an event, and whenever I'm saying probability of some random variable x equal to 3, then you should be understanding that this is an event. This is also an event. Why? That I will tell you later. Okay, currently you understood that these things are event, right? I mean, like, what do you understand from the event? What do you understand from the event? Any subset of sample space. Subset of sample space is an event, right? Don't worry about the probability of that event, right? Maybe, maybe some subsets are too naive to discard. I mean, some subsets may be too useless, and their probabilities might be 0, right? Some subset might be having, let's suppose the phi. This is a subset which is having probability 0. Maybe. Let's not worry about the probabilities for now. But I hope you understood that what is an event. You collect all possible outcomes, right? Head, tail, maybe head, tail, head, tail. Anyway, like you collect all possible outcomes, and then what you do? You take the subsets of this. You take the subsets of this, and this is called event. Yeah, cool. Now let's just continue with the random variable. For now, let me know if the basic definitions are clear or not, and then we can continue with the random variable. So basics we have covered. What is the probability? Probability is basically something which is denoting that on an average, if you perform experiment, or maybe if you perform the experiment enough number of times, then you will be getting head or tail or something like this if you do enough number of times. So basically probability tells about the enough number of times. If you do enough number of times, if you do enough times. Now don't come to me that what is this enough, okay? These are just theoretical things. I cannot give you the numerical value of this enough, obviously, right? So that's what we have defined. Now then afterwards I just told you what is the sample space, right? What is the sample space? What is an event? And how probability is actually related to this, right? Sample space is set of all outcomes, set of all outcomes, and event is some subset of sample space, right? Cool. Okay, let's just continue further. Let's just see what is a random variable. So what is random about it and what is variable about it? We need to understand both of them. Let's just do it step by step. Before that, I have a good news for you. Not really a good news, but it is a good news in the sense that even though this chapter of random variable seems to be covering a lot of new ground, but this is not really the case. That's the good news, which means that you might think that I'm going to cover many of the new things. No, I will just cover the old things. I will just relate them to random variable. I will again talk about the event, but this time in form of random variable. I will again talk about the Bayes theorem, but this time in terms of the random variable. So whatever we have studied previously, right, we will talk about the same thing but in terms of random variable. Actually this random variable is very tightly coupled with the event. Okay, so till now, I mean, before the random variable, I'm assuming that you have studied basic things. Like till now, we have studied what are those events or and what are the base theorem, conditional probability, these things, and these conditional probability or whatever it is, right? These are basically, sorry, these are just I mean some form of random variable. Basically the random variable and these two things are tightly coupled. So I will be just talking about the old things only, but in new way. That's the only thing. Okay, so in this chapter we will simply take concept from the chapter 1, which are the probabilities, conditioning, independence, and apply them to random variables instead of events. So instead of the events, now I will talk about the random variable. And before that, obviously I have to define what is a random variable, and then we will be seeing what is the tight coupled relation between the random variable and the event. And once you are convinced, not just convinced, once you are get happy, once you feel amazing that, oh, that is the relation between random variable and event, then we will move to the actual concept of the random variable, which are mean, variance, probability distributions, like that. The probability mass function, variance, mean, and the distributions like binomial distribution, one knowledge distribution, and so on, right? Okay, so let me know if you have understood everything till this point. Cool. So let's just first have random variable definition in place. So what is a random variable? Random variable, okay, let me just in short, let me just denote it by RV, which is random variable. It is a it is a function, okay, it is a function that maps something from the sample space, basically like every outcome from the sample space, function that maps, okay, which is interesting. It is a function that maps outcome from sample space to real numbers. Okay, let me know if that is clear. Yeah, thank you so much, Rohit. No, now what do I mean by the function? Let's just see. Suppose you have some outcome here, you have some outcome here, you have some outcome here. What this random variable will do, it will take every value from the sample space. It will say that, okay, let me map it to the real line. Okay, it will map to the real line. That's the only thing that this random variable does. Let me give you the examples. Okay, maybe let me give you the examples. Okay, or maybe I can go to that page only. Yeah. So let's take an example of tossing a coin where the head and tail the only possibility. Okay, let me define a random variable x. Okay, random variable x which maps head and tail, okay, which are the outcomes, to the real line. So what I'm saying here is that x is a function which will take head as its parameter. It will map it to a real line. So this real line could be anything. Let's suppose x of h is 5 and then x of t is, let's suppose, 100. Suppose I define x such that x of h is coming out to be 5, x of t is coming out to be 100. Okay, I mean this is a random variable which is a function you can define in your own way. It is some random variable which are taking these two values. Okay, suppose I am doing so. Let me know if that is fine to everyone. So I can definitely do so, right? Okay, so what I'm doing, I'm defining a random variable. Yeah, so just give me a second. I think it is not visible properly. Yeah, I think now it will be visible, right? Okay, so I'm defining a random variable which is basically mapping my head and tail to 5 and 100. Now what do I mean by that? I am saying that this is a function which takes some outcome. It is mapping to some real line, right? Now suppose I say what is the probability, okay? What is the probability that x takes the value 5? Then you will say it is same as the probability that head comes, which means 1 by 2. Okay, so I will go slowly. The notations might not be that much clear that how I'm writing equal to in case of function, right? I mean, I'm supposed to give some parameter here. I will come to that in just a moment, but just to give you the broader idea that what we are going to project here is basically we are going to relate the event and the random variable. So random variable can take any value, and then on top of that you will be defining the probability that okay, this random variable takes the value 5 is same as saying that what is the probability of n. Okay. Okay, cool. Anyway, I will talk about this little later. But for now, we need to talk about what are these random variables. Let me know if things are making little sense. So what we are doing here, we are actually just having some random variable which is x, and now we are saying this x can take head and x can take tail, and it can map it to the number line, right? And the values could be anything. It is your choice, whatever value you want to give. Cool. Okay. Now let's suppose I say let me have some diagram here. Okay. So let's suppose that I say that I define my random variable x which is looking like this. I define my random variable x which is basically taking the head and it is mapping head to 2, taking the tail, it is mapping tail to 2. Now tell me what do I mean by saying that x equal to 2. Okay. So basically I'm giving you a random variable x which is mapping head to 2, tail to 5. Now I'm giving that to you. Okay. I'm giving that to you. Now sometimes instead of writing x of h equal to 2, instead of writing like this, I will be changing my notations. Okay. So instead of writing like this, I will just say that x equal to 2, which automatically means that I am talking about set of all outcomes. Basically this is just one thing where I am saying that x of h equal to 2 which is given to me. So instead of using this notation, I will be using this notation. Okay. And I want to use this random variable just like a variable, not as a function. That's the idea here. So it seems like random variable is a function, as I told you, it is in fact a function, but for my convenience, okay, for my convenience, I will treat this random variable just like a variable. Okay. So basically, I will say x equal to 2 instead of saying x of h equal to 2. So here, I am treating it as a variable, although it is a function, right? So x equal to 2 basically means it is set of all outcomes w or omega where x of omega is equal to 2. Basically, it is a set. It x equal to 2 is a set. And what do I have in this set? Set of all outcomes which x is mapping to 2. Currently, it is mapping to just head. So this set is having head, right? Okay. Let's just take more examples and let's see if you understood something. Let's take more examples. Suppose I define a random variable. There are different outcomes. Okay. Maybe let me say these are the outcomes, and which are, let's suppose, 1 2 3 4 4 5 6. Suppose I roll a coin. Oh, sorry, a dice. Okay. Suppose I roll a dice and I can get 1 2 3 4 5 6. I define my random variable such that this is mapping 1 to maybe anything. Okay. Maybe 10, 2 to 2 to also 10, let's suppose, 3 to also 10. Okay. Like just for the sake of example, and maybe 4 to 5 something, 6 to maybe 3, and what else is remaining? Yeah, 5 to, let's suppose, 0. Okay. So 5 to 0. Suppose this is my random variable which is mapping something like this, which means it is mapping 1 2 3, these 1 2 3 to 10 actually, and 5 to 0, 6 to 3, and 4 to 5. Let's suppose this is my mapping. Okay. Suppose it is given to me. Now if I say that x equal to 10, then you will say it is a set, actually the set of all possible outcomes. Okay. Set of all possible outcomes where x is mapping to 10. Now can you tell me what are the elements in this set? What are the elements in this set? If this is a set, then what are the elements in this set? Let me know. Okay. So I think you will say the outcomes here will be 1, 2 and 3 because it is mapping 1, 2, 3 to 10. So let's suppose if I just ask you what is the probability that x being 10, you will say this is the same probability of 1, 2, 3, right? The probability of 1, 2, 3. Basically anything which I am writing here x equal to 10 or something, it is just a set. It is just a set. Let me know if that is clear to everyone. Okay, everything which I am writing here is just a set, right? Now tell me if I just ask you that x equal to 5, then you will say it is also a set where it is containing 0. If I say x equal to 6, it is also a set which is containing 3, right? Okay, so I hope it is understood to everyone. Cool. Now let's just quickly jump to so this is basically what I'm defining as a random variable. Let's quickly jump to more things and then we will be talking about some gate questions. So now you have understood that random variable x equal to anything 10, it is a set, right? It is a set. More formally, it is a set of all outcomes outcomes where x maps to 10, right? So mathematically I can say that it is omega where x of omega is actually 10, right? So x, instead of saying all of this story, I will just use like x equal to 10. So that's just for my mathematical convenience. Okay, so that's why I will be calling it is a variable. I will be calling this is a variable. Why? In fact, it is not a variable. I will be just calling for my sake of convenience. Otherwise, theoretically, mathematically, it is not a variable. It is a function. Just because for my convenience I want to use it, I am calling it as a variable. Let me know if that is clear. Right? Okay. So I will be calling it as a variable, right? Now tell me, if I just take one more example quickly, let's suppose, okay, yeah. So let's suppose if I take this example, is this visible to you guys? So here what I'm saying is that this is S1, okay, this is some S1, some outcome, this is some S2, this is S3, this is S4, or maybe if you want, let me just call it 1, 2, 3, 4. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And suppose I'm mapping maybe 2 and 4, 2 and 4 to 0, and rest which is 1, 3, 5, 6 to 1. Suppose I'm mapping something like this. And this is the example and of, let's suppose, fair roll of fair die rolling. Okay, this is an example of fair dice. Suppose there is some x where it is mapping 2 and 4 to 0. Okay, you can map to anything, and then it is mapping something to 1. Now if I just ask you what is the probability that x is less than 1. Okay, instead of saying x is less than 1, let me just ask you first, what is the probability that x is equal to 1? You will say it is same as saying the probability x equal to 1 means what are the all set of outcomes which are mapping to 1, which are 1, 3, 5, 6, right? So 1, 3, 5, 6. And what is the probability that you get 1, 3, 5, 6? Either 1 or 3 or 5 or 6. It is basically 4 by 6, right? Let's suppose everything is equally probable. Right? Similarly, if I just ask you what is the probability that x being 0, then you will say this set is 2, 4. Now, suppose if I ask you what is the probability x less than 1, then you will say the set of all outcomes which are less than 1, which means again 2, 4, right? So this is again 2, 4, basically the probability of 2, 4. X less than 2. Okay, sorry, there is something which is mapping to 4. 5 is mapping to 4. 5 is mapping to 4. That's why. Okay, suppose if I just ask you what is the probability that x is less than 2, it means it is same as saying x less than 2 means all of those outcomes, which means x less than 2 means 1, 2, 3, 4, and instead of 5 I will be writing 6, right? Like except 5 everything is mapping to less than 2, which is means either 0 or 1. Let me know if that is fine, right? So basically what I'm doing here, I'm either writing x equal to 0, x less than 1, something, right? Something, whatever I'm writing. Based on that, I am writing some set. I'm writing some set, and this set is actually basically having some outcomes. Which means that whenever I write x equal to a or maybe x less than b or something like this, these are basically some conditions on random variable, right? Some condition on random variable. It's just a set. Let me know if that is clear to everyone. And this is just a set which is in fact an event. This is in fact an event. Why? Because this is a set of some outcomes. Set of outcomes. And set of some outcomes is actually an event. So whenever you are saying x equal to 2, it is an x equal to a, it is an event. It is an event. Whenever you are saying x less than b, it is an event. So why it is an event? Because these are just sets. See, this is set, this is set, this is set, this is set. So everything is set. So any condition on random variable is actually a set. Okay. I hope that is fine to everyone. Now, what will we do? We will basically say that any condition on random variable is an event. Since it is an event, I can define a probability on top of it, which means I can define a probability x less than a. This is a valid probability. Why? Because the probabilities are defined for the event, and this is an event. This is an event. Similarly, I can always write x equal to b or something, right? This is also valid. Why? Because the underlying things, this is an event. Okay. So I hope that is clear to everyone. That what is a random variable? So any condition on random variable is an event. Now let's just make it more interesting. Okay, let's just make it more interesting, and let me ask you a couple of the questions, and then we will be through understanding. We will be having a thorough understanding of random variable, and then we will be probably switching to the questions. Okay. Suppose you define your random variable such that you have some outcomes. Okay, you have some outcomes which are, let's suppose you can get either one. Okay, you can get 1, 2, maybe you can get 3, 4, or maybe you can get, let's suppose, 5. So these are the 6, let's suppose, possible outcomes that you are having. Okay. Now there will be some probabilities of these possible outcomes. Let's suppose I'm writing the probabilities here. Let's suppose that everything is equally probable for my example. Let's suppose it is 1 by 6, 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 it is 1 by 6. Now let's suppose there is a random variable x which is mapping 1 to something. Okay, maybe I don't care, maybe 100 something. Okay, maybe 1 1 2 2, maybe it is mapping 3 to 2, 4 to 2, maybe 5 to 3, 6 to 3, something like that, right? So this is given to me, right? I mean, that has to be given. Now they're asking something on top of it. Now suppose they're asking that what is the probability that x is 1, then what you will say? It is same as saying that either outcome is 1 or outcome is 2, because this is a set, right? This is a set which is actually 1 2. So you will say this is 1 by 6 plus 1 by 6, which is actually 2 by 6, right? Which is 1 by 3, isn't it? So you can calculate the probability. Similarly, if I just ask you what is the probability, I mean any other probability, whatever it is, right? So if I just ask you, let me just take it on the side. What is the probability that x takes the value maybe 3? Then what you will say? It is same as saying it outcome is either 5 or 6, which means 1 by 6 plus 1 by 6. You will add all of this probability. Okay. Suppose if I ask you what is the probability x takes the value 4, what you will say? Since there is no associated outcome, so it means that it is 0, which means that in terms of mathematical notation, this is an event which is actually not containing anything, which is phi, right? It is an event which is actually not containing any element which is phi. So probability of phi is actually 0, right? Like that you can understand. Let me know if that is clear to everyone. Okay. Now you can make any number of examples. Now suppose instead of this x, I give you some other x. Okay, let's suppose this time my x is mapping everything to 1. And if I ask you what is the probability that x being 1, then can you quickly tell me what is the probability that x being 1? It is just 1, right? What is the probability? Because it is set of all outcomes which is just 1. What is the probability x being 0, or maybe some other number x being 2? then you will say it is 0 because x is not mapping to anything else, right? Now I give you another random variable and I say, okay, let's suppose this time I'm giving you a random variable which is looking like this. I say what is the probability x being 1, you will say 1 by 6. What is the probability x being 2, you will say 1 by 6, something like that, right? How you are calculating this? You are basically finding out the underlying outcomes. Otherwise you cannot calculate it, right? You are finding out underlying outcomes, x being 1, x being 2, something like this. Okay. Let me know if this was a simple thing, but I know like it should be clear. Then only we will be moving further. Okay. Suppose just for the sake of last example, suppose if I give you some example where I do not have the equal probabilities. I mean, you do not need to have the equal probabilities, so that's why I'm giving you some random probabilities maybe. Suppose this time I give you the probabilities, which is, let's suppose it is 1 by 2, 1 by 3, and the remaining probabilities are just 1 by 24, 1 by 24. Maybe let's suppose it is also 1 by 24. This is also 1 by, okay. This summation is 1. And then I'm giving you any random variable, maybe it is 1 0 1 0 or some random variable, okay, and this is 2 1. And suppose if I just ask you what is the probability that x being 1, now tell me, just tell me what should I sum, where is the x1? Here, here, here. What are the associated outcomes? Maybe 1, 3 and 5. What are those probability? 1 by 2, 1 by 24 plus 1 by 24. So you will be just adding the associated things, 1 by 2 plus 1 by 24 plus 1 by 20. Let me know if that is clear to everyone. Right? Similarly, if I just ask you what is the probability x being 0, you will be adding 1 by 3 and 1 by 24 because there only x will be 0. So it is 1 by 3. Like that you can find these probabilities. Not a great deal, right? Now, interestingly, what will I do? From now on, since I want to use this as a variable, right? I don't want to cross check that what is the associated set with this. So I will just do one thing. I will not reveal this information to you. Okay. So we will go in the abstract way. I will not reveal what are the outcomes and all. I will not reveal this. I will just tell you PMF. PMF means probability mass function. Okay. From now on, what will I do? Yeah. So from now on, we will be directly working with the probability mass function, which is called PMF. Okay. Let me show you how. So instead of giving all of this, I will just say that see the probability of x being 1 is something, probability of x being 2 is something, probability of x being 3 is something like that, right? I will just give you the probabilities of x directly instead of giving you the probabilities of outcomes. And then I ask you to find out the probability of some x equal to 2 or something. Then you will be checking what are the associated events and all, right? I don't want to do this extra work. So from now on, I will just extract away this outcomes thing, right? I will just not reveal this outcome and all. Okay, earlier, just for the sake of simplicity or for the sake of example, I'm telling you, but now we will not tell. Okay. So Khoshit is asking what is the probability x is less than 2. In which example? Actually, there are many examples. So in which example? Are you asking in this example? In this example, x is less than 2 is basically either it is 1 or 0, right? So you will be adding all of these probability apart from the 2. Cool. Now, I hope you understood this. Cool. Now let's just make it little more interesting, and then we will be actually moving to the discrete random variable. But before that, we should be checking that I mean what this random variable is. Let me ask you a question which is true or false. Suppose I say that there is some event which is x equal to a. Okay, generally we write it in curly braces. Otherwise, like don't worry. Okay, and there is some event, which is x equal to b. These are the two events, right? I mean, any condition or random variable is just an event. If I just make a statement that these events are always distinct, I mean disjoint events, then tell me it is true or false. Let me know. So what do I mean by that? See, this x equal to a is basically some event, which means that whatever outcomes are going to a, right? Suppose w1 and w2 and w3 which are going to a, which means let's suppose there are three outcomes here, which is w1, w2, w3, which are mapping to same number, which is let's suppose a, right? Which is, let's suppose w4, w5 are mapping to b, which means here I have w4, w5. Can there be any particular outcome which is common in both of the sets? Can I have w3 here and also w3 here? Is this possible? Is this possible? No, right? Why? Because this w3, if it is here, since x is a function which is also a deterministic function, I mean functions are deterministic only, right? So a well-defined function, since x is a well-defined function, it means that if it is mapping something, let's suppose w3 to a, then it cannot map w3 to b also, right? So there cannot be some outcome which is mapping to a and b both. This is not possible. Since it is not possible, that's why you will say that yes, yes, this is always true, which is that you will be saying these two events are always disjoint, right? So you will be saying that these two events are always disjoint. So here I will be making a claim that yes, it is true. Why? Because there cannot be any outcome which is here also, which means it means that it is mapped by x1 to a also and b also, and it is not possible, isn't it? Okay. Cool. Suppose, let me ask you another question, which is also true false. Let's suppose that x takes only or only four values. Let's suppose, which means that whatever the outcome here is, okay, whatever the outcome here is, x is mapping to either, let's suppose, a or b or c or d. Okay, I mean everything is either mapped to a, b, c or d, something like this, right? Suppose everything is either mapped to a, b, c or d, something like this, right? Which means x is actually just having the four values. For everything, it is either giving a, b, c or d. So now tell me that if that is the case, then saying that it is, let's suppose, four values, which is a, b, c, d, then this x equal to a, x equal to b, x equal to c, and x equal to d, x equal to d. These four events, can I say these four events are mutually exhaustive, which means they cover all sample space. Exhaustive, mutually exhaustive means they cover sample space. Can I say that x equal to a, b, c, d, if x can take four values, then I'm writing all of the four values whatever x can take, then it will be mutually exhaustive? Answer is yes, because if something is mapped by a, I will be writing all of the things, w1, w2, everything which is mapped by a, everything which is mapped by b, everything which is mapped by c, everything which is mapped by d. Since x can take only four values, then it means that my outcome either be mapping to a, so it is here, or maybe b, or to c, or to d. So anything I pick will be either in this set, this set, this set, or this set. So definitely it is a mutually exclusive exhaustive set, right? I hope you understood. Which means I can definitely say that if x is taking whatever values x is taking, let's suppose it is taking just four values in my case, then all of the outcomes either it will be basically mapping to a, b, or c or d. So I can definitely say that this probability is always 1. This probability is always 1 because x is mutually, I mean these all events are mutually exhaustive. Okay. In other words, I can say summation of all probabilities that x can take, okay, I mean all the values that x can take, it is always 1, right? Because every outcome will be either mapping to I mean one of the value basically. Let me know if that is okay to everyone. Okay. Now, I hope you have understood everything. Just one last question. Okay. Just one last question. Let me just ask you that suppose if I just give you A B C D, that X is taking, let's suppose A B C D. So let me just paste it here. So let's suppose X is taking A B C D. Then can I say that if X is taking A B C D, that X equal to A, X equal to B, X equal to C, and X equal to D is a partition. Partition means, okay, this is a set theory terminology. Okay, partition means it is mutually exclusive and exhaustive. These sets are mutually exclusive also, which means no outcome is common here, right? Similarly, this is exhaustive. Exhaustive means that if you have all of them, then you are exhausting the set. Can I say something like this? The answer is yes, right? So answer is yes. So basically, if I say it is true or false, then this is also true. Okay. Anyway, let's not worry about it. But I just wanted to tell you that if you are writing X equal to A, it is a set, and you are actually finding out the probability of this set, right? Now, if you are writing two things, okay, if you are writing two things, then let's suppose probability of X equal to A or X equal to B. Let's suppose you are writing two things. If I just want to know what is the probability of X equal to A, X equal to B, or X equal to B, then actually you can just sum them up. Why that is the case? Because these two are basically two events which are mutually exclusive, right? No event is common here, so you don't need to subtract some intersection part. Actually, because there is no common, so you will be just getting it 0. I mean, even if you subtract. I mean, if someone asks you X take value this, then you can just sum those probabilities, right? You can definitely sum them. So there is no issue in summing them. Cool. I hope you understood this thing also. Now let's just go and see that what are those random variables and how they are useful to me. So just to sum up, what is a random variable? It is actually, as I said, it is actually a function, right? It is a function, and since it is a function, it cannot be a variable first of all, and functions are deterministic, right? So I can say, in other words, I can say a random variable is, if random variable I say if it is X, then it is a deterministic. It is neither random nor it is variable. It is, in fact, it is deterministic, and it is a function. It is not even a variable. Then why people are interested in saying the deterministic function to be a random variable, which is completely opposite of the definition that we have just studied? Why people are so interested and so fascinated about saying this deterministic function as a random variable? Can anyone tell me? It is just see, why I'm calling it variable, just for my convenience. So this is, I mean, in fact it is a function, but I want to use it as a variable, right? I don't want to write x of h equal to 2 like that, right? I don't want to write it. I just want to write x equal to 2. So since I'm using it as a variable, that's why it is called variable, right? Because I'm using it as a variable, that's why I like to call it as a variable. Because I just want to give you a false feeling. Always I want to give you a false feeling that it is a variable, it is not a function. Okay, just to hide everything abstractly, I want to call it as a variable. See, I told you that I will be hiding these things. I told you that from now on I will be hiding this outcomes and all, and I will be just giving you like this, right? Which means I want to treat this as a variable. That's why I will be calling it as a variable. Okay, cool. I hope that is understood, that I will be I will be calling this a variable. That's why I just want to call it variable. But what is so random about it? There is nothing random about it. This is a deterministic function. Still, I am saying it random because it's, first of all, there is no reasoning. It just sounds fancy. It is like, if you want to find out the reason, it is just because that whatever the outcomes we have, or whatever the experiment we have, basically this experiment is a random experiment, which means that you don't know what's going to happen. There is no certainty, because like probabilities are associated with it. The experiments are random, that's why I'm calling it a random variable. Okay. So anyway, like there is no reasons behind it, like why it is called random variable, even though it is a deterministic function. Like I can tell you why it is called variable, and I can also tell you what is called random. But it doesn't mean that you may get convinced or you may not get convinced, because these are not theorems of which I am telling you. Okay, it is just some probable reasons that I am telling you. Okay, if you say I'm not convinced, then it is your choice, right? I mean, you get convinced or not, I cannot convince you, because this is not a theorem where I can convince you. It is just some mathematical convenience for which people are using. Okay, cool. So from now on we will be just calling it a random variable, and we will be having a false feeling that it is a variable. Okay, I don't want to ever say that it is a function. Now from now on I will just say it is a variable. Let's continue with this. Now, suppose I have an example of of tossing a coin. Let x be a random variable which takes value 1 on head and 0 on tail. What is the probability that x being 1? So we are saying it takes value 0 if head comes, takes value 1 if tail comes. And now, or whatever, right? 1 if head comes, 0 if tail. Now they are asking probability of x being 1. It is same as saying the probability of head, right? Which means that let's suppose it is a fair coin. Okay, it is a fair coin, then it means it is 1 by 2, right? Probability of x being 1 is same as 1 by 2. Cool. Now let's do this. Let's suppose I define a random variable x. I define a random variable x1. I define a random variable x2. And what are these random variables? It is basically mapping number of heads on the first flip. It is saying number of heads on the first flip. If you toss this coin twice, okay, if you toss this coin twice, then they are telling that they are defining some random variable on the experiment where they are tossing the coin twice. Okay, so let's just do it. X is number of heads that appear on the both flips. That's what they are saying. So what are the possible outcomes? Maybe head. Okay, if you are doing it twice, maybe first time head, tail, head, and tail, right? So these are the 4 possible outcomes. Cool. Now they have defined some random variables, and then they have asked some probabilities. Let's just do it, right? So tell me, what are the associated probabilities? Probability of head will be what? What are the associated probabilities? So let's just write the associated probabilities. So these are the possible outcomes. Before I go to the random variable, let me just work with the the sample space. So let's suppose the coin is fair. So the probabilities are, let's suppose 1 by 4, 1 by 4, 1 by 4. Okay. Now these are the probabilities that I have. These are the outcomes that I have. Now let's suppose I'm writing x1 here. Tell me the value of x1. X1 is number of heads on the first flip. Number of heads is 1 here. Number of heads first flip 1, 0, 0, right? What is x2? How they have defined the x2? It is our choice. X1, x2, any random variable is our choice. How with the help of English I am mapping, or mathematically directly I am mapping. It is my choice, right? Okay. Tell me what is x2? Number of heads on the second flip. So I think it is 0. Sorry, on the second flip it is 1. It is 0. 1, 0. Cool. What is x? Let's just see x later. Okay, maybe I can also draw the x. Number of heads after the both flips. Number of heads here is 2. Number of heads here in the both flips is 1. Is 1 is 0, right? So this is x. Anyway, don't worry about it. This is just English. I translated that to table. Okay. Now tell me, what is the probability that x is less than 2? You will just say that, okay, this is where, okay, sorry, not this. These are the 3 things where x is less than 2. So which means you will say that, okay, these are the 3 things which are mapping less than 2. You will sum up all these probability, which is 1 by 4 plus 1 by 4 plus, right? Like that only. Now, interestingly, they have something here. We are saying x1 plus x2 is less than 2. Till now, I haven't dealt with these kind of things. I have dealt with the random variable directly, not with the function of random variable. So this is a function of random variable, right? Of random variable. Till now, we have not dealt with this. Okay. So let's just deal with the function of random variables, and let's see that how we can solve these questions. So suppose they're asking what is the probability of x1 plus x2 is less than 2. Then you will say that see, it is a function of random variable. I don't know anything about x1 plus x2. So why not I define a new random variable y, which is actually x1 plus x2. Okay, which is a function of x1 plus x2. So let me just write y here. This is 2, this is 1, this will be the summation I am writing, right? This is 1, this is 0. Okay. Oh, that happens to be x. That is same as x, maybe a coincidence. Let's not worry about it. Okay, this is same as x, but let's not worry about it. It might be a coincidence, maybe well planned coincidence also. Okay, but let's not worry about it. So this is y. Now basically they are asking probability of y is less than 2. Now you can calculate, right? This is 2, which is, I mean, these three things. So you will be actually saying 1 by 4 plus 1 by 4. So basically, whenever they are saying that there is a function of random variable, why don't you have a PMF itself? PMF means probability mass function. It is basically the probabilities of all possible values of y. So these are the possible values of y, and I have the corresponding probabilities, right? Similarly, if they ask you probability of y being 1, or maybe they say x1 plus x2 being 1, x1 plus x2 being 1, then you will say, okay, these two things are leading to it. So you will say this is 1 by 4 plus 1 by 4, which is 1 by 2. Let me know if that is fine to everyone. Okay, cool. So I hope that is understood. Now let's just do one last example, and then I think we are all set to understand this random variable. Suppose there is a random variable x which I define the sum of scores on 2 dice. Okay, I can define any random variable, anything. So basically, you are tossing a die 2 times. So tell me what are the possible values of x that you can get. Maybe x can be, if you are tossing it 2 times, you are defining some of the outcomes, some of the scores. Minimum value could be 2, right? And 3 could appear, 4 could appear, and I think till 12, right? 5 can appear, and till 12 it can appear. So these are the possible values of x. Now they can ask you what is the probability that x being 5. You will say it means x can come 5, x is 5, which means either 1 4 or 4 1. So these two events contribute to this, right? Which means everything. So here every pair is having 1 by 36 probability. So that's why. Okay, sorry, not just these two, 3 2 and 2 3 also. Okay, every pair is having 1 by 36 probability. This is 4 by 36 probability, which is 1 by 9. Yeah, I hope you understood this. So basically, they will be defining a random variable, and we should not worry about it, and we should be just treating the random variable based on the outcomes. If the outcomes are given, otherwise we can do the questions normally. Okay, so now you know what is an event. I mean, you already know what is an event, what is a random variable, right? Now, and you know the relation between them. So any condition on random variable is just an event. Cool. Now let's just see this, what they are asking here. Let's just try to understand this. So they are saying that you have given some mapping. Okay, they have given some mapping to you, and then they are saying, tell me what is the probability x is less than 1. You will say, okay, x is less than 1 means it is 0. So let's suppose everything is equally probable. There are two things which are mapping to this. So out of 6 things, right? So 2 by 6. 2 by 6 is the probability that x is less than 1. What is the probability x is less than 2? You will say, okay, these are the things which I think 5 by 6, right? X is between 1 and 2. Can anyone tell me what is the probability that x is between 1 and 2? Let me know if you have understood these things. Tell me what is the probability that x is between 1 and 2. See, no outcome is mapping here, right? In one, strictly less than 1 and strictly greater than 1, strictly less than 2, so it is 0. X less than or equal to 4, tell me what is the probability. If x is less than or equal to 4, every outcome is mapping here, so that's why it is 1, right? Okay. Now let's move to little advanced thing. Suppose they say probability of x equal to, oh, generally you write probability of x equal to 1, 2, 3, or maybe you can write k in general, or maybe you can write small x also, right? So either you write say x equal to 1, 2, 3, or maybe you write k here, or maybe you write small x here, does not matter. So basically this thing, whatever I've just given to you, this is called probability mass function. Probability mass function means that you have the mass, okay, you have the mass, a probability mass of every value, which means for every value you know that what's going to happen, which means if I just say that what is the probability here the x can take the values -4 to 4, right? I mean, if x is taking the value -4, you know the probability is basically 1 by 9. If it is taking, let's suppose -3, then 1 by 9, -2, 1 by 9. This is given to me, right? -1, 1 by 9, 0, 1 by 9, and so on. So these are the probability masses that you have. These are the probability masses, right? So anyway, this is called the probability mass function. What is the probability mass function? That if you list out all the probabilities for any random variable, then it is called probability mass function. Okay. So now suppose if I just ask you simple question, which is something like this, which is actually, I mean, very trivial question now, which is something like the probability of x being -4, you will say it is 1 by 9. If I just ask you probability of x less than or equal to 0, then you will say, okay, let me add all of this, maybe 5 by 9, right? Something like this you can definitely do. Now let's just do one thing. Instead of asking for the x, let's define a random variable y, which is a function of x, and then let's just ask the probabilities over y. Okay, so here I'm asking the probabilities over y instead of the probabilities over x. So let's just say I'm asking probability that y being 2. Then you will check that, okay, what are the values where, what are the possible values of y? Let me just ask you this thing first. See, 4 is a possible value because -4 here, then it will be 4 actually. So if I just write in the increasing order 0, 1, 2, 3, 4. These are the possible values of y. What are the possible values of x? There are many. Starting from -4, -3, -2, -1, 0, 1, 2, 3, 4, right? There are many possible values of x, but there are only few possible values of y. Let me know if that is clear to everyone. Okay. Now, suppose I ask you that what is the probability, maybe x y is 2, then you will be saying that, okay, let me do one thing. Let me first make a chart, okay, which means x can take -4, -3, -2, -1, 0, 1, 2, 3, 4. These are the values x can take. This is x with the probability 1 by 1 by 9, okay, equal probability of everything. Now you will say, okay, let me first make a chart where everything is taking 1 by 9, 1 by 9. Just for the first example, I am doing it, and then we will be seeing how to do it for the function of the random variable, right? Now you have y here. Now you will say that, okay, this y will be taking the value 4 here, 3 here, 2 here, 1 here, 0 here, 1 here, 2, 3, and 4. Now if someone asks you, what is the probability? What is the probability that y is 4 or y is 2? What is the probability that y is 2? You will say that, okay, y is 2 here, y is 2 here. So you will add both of these probabilities, which is 1 by 9 plus 1 by 9. So if someone is asking you about the function of random variable, then what you did, you found out the PMF of it. PMF means listing out all the possible values and then corresponding probabilities, right? You found out the PMF of it, and then based on that you are calculating. Or in other words, what you can do, if someone is asking y equal to 2, what is the probability of y equal to 2? You will check what are the all possible values of x which are contributing to this. Then you will find out these are the values of x. So you will say that, okay, instead of doing all of this drama, I will just do this. Probability of x equal to 2 plus probability of x equal to 2, right? Which is actually 2 by 9. So I will be directly doing this instead of finding out the PMF. Okay. So suppose if I ask you what is the probability that x is 4, or sorry, y is 4. So if I just ask you what is the probability that y is 4, then you will check that what are the values which are contributing to 4. You will say -4 and 4, right? These are the x values which are contributing to this. So that's why it is again 2 by 9. Now if I ask you what is the probability that y is 0, then you will check what are the possible values which are contributing to this. Then you will say, okay, only x equal to 0 is contributing here. So this is just 1 value, right? So that's how you can calculate the probabilities of y. Cool. I hope you understood. Now let's do few questions. Okay. So let's do few questions now. Suppose x and z are two random variables which are associated like this. I mean, they have defined a function of random variable y, which is x or z. They have given the PMF. Okay, I mean, PMF means probability mass function means for every possible values of the random variable you have the answer, right? You have the probability. So for x equal to 0, what is the probability? For x equal to 1, what is the probability, like that, right? So they have given the PMF to you. Okay, they have given the PMF of z also. So the PMF is given to you, and let's suppose they're asking some particular value, maybe, right? Maybe they're asking what is the probability that y being 1. Tell me what you need to do. You need to basically check that how can y be 1. Y being 1 means probability of they're asking x or z being 1, right? So what are the possible values of x and z which are contributing to this? See, let me do a table wise first. X and z are this, which can have 0 0, 0 1, 1 0, and 1 1. These are the four values. This is y, which way they have defined x or z, right? And they have said this is jor, which means 0 1 1 and 0. And then they are asking the probability of y being 1. Then you will say, okay, these two values are basically contributing, which means this row and this row. Now it is interesting, right? Because they have given individual probabilities. They are saying that x0 is p. Okay, so they are saying that this probability that x being 0 is p. This probability that by z being 1 is 1 minus epsilon. Okay, this is 1 minus p, this is epsilon. So the individual probabilities are given to me. Now what is the probability that x is 0 and z is 1? Suppose these are independent random variables, right? So I mean x0 does not impact z being 1 or 0, right? It will take 1 with independently that x has taken 0 or 1, right? Which means that this pair probability is p into 1 minus epsilon plus, or maybe this pair which is 1 minus p into epsilon. Basically probability of y being 1 is same as saying probability of x being 0, and this comma means and. Okay, either you write intersection, or you write comma. Basically both are the same thing. In case of event, generally I write a intersection b, but in case of random variable, instead of writing intersection, I write comma. I mean you can use both the notations in both the places, which means you can use p in a intersection b in case of events, which is same as saying p a comma b also, right? Or maybe probability of, you can also say in case of random variable x being 2 comma y equal to 3, which is same as probability of x equal to 2 intersection y equal to 3. I mean either you use comma or intersection, this is just a notation. Okay, so I'm using the comma in case of random variable, generally comma is better. Okay, z equal to 1, so either this pair x equal to 0 and comma means and. Okay, so this means and. You take z equal to x equal to 0 and z equal to 1, or you take x equal to 1 and z equal to 0. Since these are independent random variables, you can actually just split this probability x equal to 0 into multiplied by z equal to 1, right? Because these are independent random variables. And that's how we can calculate this probability. Let me know if that is fine. Now, let's solve one gate question, okay, which is this. Now, before that, let me just ask you maybe some more things here. Yeah, so tell me, what are the probabilities that y0? You will check what are the all possible things. Y0 means probability of x George z equal to 0, which means probability of x being 0 and see this is set, and z being 0, or x being maybe anything, 1 and z being 1, right? So these are the two possibilities where you will be writing. I hope you understood. Okay, cool. So you can sum all of this. Now let me ask you another question, maybe here. tell me here only conditional probabilities. Now let's just ask something interesting, where I'm just asking you what is the probability that y being 1 given that x is already 1. Okay, you will say it is same as saying probability of x George z x George z equal to 1 given that x is already 1, right? Now there are a couple of ways to do it. So they are saying what is the probability, which is actually a gate question also, z x George z equal to 1 given that x is equal to 1. What you can do, you can use the a and a probability of a given b formula, which is probability of a intersection b upon probability of b. So let me do using multiple ways, and let me just call this way as method 1. Okay, so that you get to understand things more clearly. So let me just see this particular way as method 1, where I'm using this formula. Now you will say probability of x dot z given x equal to, okay, x dot z equal to 1, given x equal to 1 is same as saying probability of x dot z equal to 1 and, or maybe comma, whatever, right, comma, x equal to 1 upon probability of x equal to 1. Okay. Now tell me, are these two events independent? Are these x equal to 1? Say earlier these used to be independent, right? Earlier these used to be independent. Now tell me, are these two events independent? This is going to be little interesting. Let me know. Obviously no, right? Because this is involving x. So in such a case, how to solve this joint distribution? Okay, don't worry about the joint and these terminology, but anyway, these are called joint distribution if you have two random variables, something like that, right? See, this is a function of random variable. Let's suppose by, right? This by and x are not independent. So how to solve it? If these are not independent, you can definitely not separate them out. Definitely, that is for sure. Then what you will do? You will basically see if you can put the values, right? If you can put one of the value here. So you can definitely do it. Basically, I want to find out probability of x dot z equal to 1, comma x equal to 1 upon probability of. So you cannot separate them out because this is a function of random variable which is y, let's suppose, and this x are not independent because it is a function of x. So how can it be independent? But if it is n, then you can definitely put the value here. So you can say this is same as saying probability of 1 dot z equal to 1 upon probability of x equal to 1, which is same as saying, can you tell me when can z be 1? Sorry, 1 dot z can be 1. I think z has to be 0, right? The only case. If z is 1, it will not be 1. Okay. So which is same as saying probability of z has to be 0 divided by probability of x equal to 1. And this is given to be epsilon. This is given to be 1 minus p. So that's how you can calculate this. Right? Let me know if you have understood this particular thing, whatever I'm explaining to you. Okay. Cool. Now, now let's just move to the method 2. Method 2, where it is saying x equal to 1 is known, and then they are asking the probability of this, right? Earlier what we did, we basically separate them out using the formula, but now if it is given to you, then why don't you put the value directly, right? So you can say you just remove this out, you just use this information because it is given to you, you just use this out, you just say this is 1. Okay, I think that that is okay, but that will be needing a little more thing that I want to tell you, or maybe it will be little. It will take little more time. Actually, I want to tell you the reduced sample space. So in the reduced sample space, we can work, but that will be. I mean, for this point in time, we can skip it. I think for now. Okay. So anyway, let's just skip this method too, which is actually using the reduced sample space. Okay, I wanted to use a reduced sample space where I wanted to work with the probabilities given that x is 1. Do you want me to do it, or I can skip it for now? Let me know very quickly. Okay, actually in the course we have done it, in the Go classes course we have done it, so I'm skipping it because it is not required. In the Go classes course I have shown you that how you can use the reduced sample space to work with, but I hope that is fine to everyone, right? Okay, now let's just probably do this gate question. What they're saying that xi can take xi for I equal to 1 2 3 are independent and identically distributed random variables Independent random variables are identically distributed, means that they are basically having the same values for all of the possible outcomes, which means that, I mean, actually this term is not even important, because they have given it mathematically also, the 0 and 1 are identically distributed, right, which is basically saying 1 by 2 1 by 2. Okay. And independent means that x1 x2 x3 all are independent, and they are saying taking the value 1 by 2 with equal probability. Define any our new random variable y, which is something like this. Okay. Now what they are saying, that what is the probability that y being 0, given that x3 is 0, right, and then it is given that y is actually x1 x2. Let me know what is the answer. Yeah, Rohit is asking that can I take a drop? Rohit, let's do one thing. You know my contact details, right? I mean, you can contact me on the Telegram. So just after the exam, just drop me a message on Telegram. Drop me a message on Telegram. We will have a call. We will have a deep dive discussion. Okay. So whatever you want to ask me, you can ask me. Definitely, we will have a call. Okay, and we will definitely have a deep dive discussion, because this is not something which I can suggest you directly. I need to understand your situation. So let's just have a deep dive call, and then from that we can conclude something. But for now, let's just focus just this 1 week. Let's not focus on anything else. Let's just focus on this gate 2023. See, after this gate 2023, whatever is your plans, whatever you want to do, we will discuss immediately after you leave your exam hall. Okay, you just call me immediately after you leave your exam hall. But before that, let's just focus on this, because there is no point in discussing now, because your exam is very near. So that's why we will be discussing all of the things immediately after you leave your examination hall, but not now. Okay. So what is the answer you're getting here? Probability of y equal to 0 and x3 equal to 0 divided by probability of x3. I think it is given to be 1 by 2. So this is 1 by 2, that is fine. Now what is probability of y equal to 0? Since you know these are not independent, that's why you can say you cannot separate them out. But what you can do is that, see, this is y, probability of y equal to 0 means x1 x2 or x3 equal to 0 comma x3 equal to 0, right? You cannot separate them out because these are not independent. So what you can do, you can put the value if you can, right? You can use this information, and then you can go with this, where x1 x2 jor I think jor x3, if the x3 is 0, then it doesn't matter, right? So it is basically saying probability of this, probability of x1 x2 equal to 0. Then what are the possible outcomes of x1 x2 that can lead to 0? Maybe x1 can be 1, x2 can be 0, right? Three outcomes, right? So 1 1 0 0 1 1 1. So everything is having 1 by 4 probability, 1 by 4 probability, 1 by 4 probability. So this is 3 by 4. So 3 by 4 into 2 by 1, which is basically something is wrong. Okay, x1 x2 equal to 0. Sorry, this is 0 0 1 0 0 1. They are taking with 1 by 2 1 by 2, and they are independent, right? Okay. X3 given to be 0, you do JOR with 0, you are getting 0. Then x1 x2 has to be 0. Okay. Can you spot if there is some error that you are able to find? Let me know if you can find the error. y equal to 0, comma x3 equal to 0, upon x3 equal to 0, you put the value of x3 and then x1 x2 equal to 0, x3 equal to 0 has 1 by 2 probability, x1 x2 combinedly 0 has 3 by 4 probability. Yeah, right. So 3 by 4 into 2 by 1, how it is greater than 1? Okay, I'm just seeing the possible error that I have done. So meanwhile, can you also try? Okay, I think that 1 by 2 division should not be there. Yeah, that is okay. There are definitely different methods. So what I'm checking here is that like what are the possible errors that we are doing? Okay. Actually, I think that x3 equal to 0, yeah, you can definitely put it, but you cannot remove this. I mean, from here, I'm saying that x1, x2 equal to 0. If you are just giving this information, then basically you are removing one of the information. So that is fine. I mean, earlier also that was the same mistake. Uh, yeah, yeah. So see here, like let me go from here. So basically, I wanted to find out that x George z equal to 1 given x equal to 1, right? Okay, just a second. So probability of x George z equal to 1 given x equal to 1. Earlier I wanted to find out this. Then what you need to do? You need to basically use okay. So either see yeah, okay, what you can do, either you use the given information directly, which means you can say 1 George z equal to 1. That is also fine. Okay, there is no problem with this. So this thing is fine, which means that 1 George z, then z must be 0, right? Which is same as probability of z equal to 0. Or you can do one thing, either you put it directly because that is known to you, right? So you can put it directly, given that it is that, because everything is independent. So even you work with the reduced sample space, actually you have to work with the reduced sample space, but since everything is independent, I mean every random variable is independent, it won't matter. But now, if you use the formula, then we can use the formula also. You can do one thing, probability of x George z equal to 1, comma x equal to 1 upon probability of x equal to 1, right? This is what we can do. Then you can put this, that's not an issue, that 1 George z equal to 1, that will tell you that z is 0, but you cannot remove this information, right? This information is always there with you, right? Earlier it is known to me, that's why I have taken this as a granted. Okay, that's called reduced sample space. Earlier I have just put it out, right? That's called reduced sample space. So basically if you don't want to do it, then also it is fine. Then you basically do it z equal to 0. If you put this value, you will be getting z equal to 0, but you cannot remove this information of x equal to 1, okay, because it is known to you also. So it is a joint distribution. In case of joint distribution, you cannot remove this. And then probability of x equal to 1, then it is same as z equal to 0 into probability of x equal to 1, because these are independent now. Earlier they were not independent. Earlier these two values were not independent, but now these are independent. So you can basically separate them out and then you can cut them out, which is actually same as z equal to 0, right? Or you can directly put it. Now similarly, so this is wrong. Similarly here, let me do this question from starting. Okay, they have asked y equal to they have given y equal to x1 x2 jor x3, and then they are saying probability of y equal to 0 given x3 equal to 0. What you can do here is basically, let me just interpret it, x1 x2 jor x3 equal to 0 given that x3 equal to 0, right? Let me just interpret it in this way. Now I'm just putting the value of I. Now what you can do, there are two ways. You can directly put this x3 equal to 0 here, that's not an issue, because you know that x3 is 0. So which is same as saying, this probability is same as saying probability of x1 x2 equal to 0, because you can directly put this x3 equal to 0 here, because you know the x3 is 0. If you know the x3 is 0, then x1 x2 has to be 0. Now basically these probabilities of x1 x2 is in actually reduced sample space. Reduced sample space means that now this is the probability that you want to deal with, right? I mean there are definitely these combinations, these three combinations which are okay, 0 1, right? So this the probability that you want to talk about. The probability of x1 being 1 should be also given that x3 is 0. But since it doesn't matter, because this x3 will take 1 with 1 by 2 probability, irrespective if x3 is taking whatever the value, right? So you actually have to, theoretically you have to work with the reduced sample space, but here this reduced sample space won't matter because the things are independent. See, now I have done this, right? I have put the value of x3 equal to 0 and I'm removing a dependency. That's fine, that's not an issue. But now whatever the probabilities I want to work with, they always have to be, I have to keep in mind that these probabilities, with respect to that, I know that x3 is 0. If I know x3 is 0, then what is the probability x1 is taking 1? What is the probability of x2 is taking 0? These are x1, x2, right? So it is basically 1 by 2, 1 by 2 only. Because x3 is 0 or 1 does not matter to me. So that's why the answer is 3 by 4. Getting my point? So basically x3 0 or not, it does not matter to me, because what I'm saying here is that you have to work with the reduced sample space, but since this x3 is independent of x1 x2, that's why it doesn't matter. So this is just a method one where you are directly putting the values. Or maybe what you can do, you can use the formula. So yeah, let me just copy it. You can use the formula which is saying the probability of x1 x2 jor x3 is equal to 0, right? And comma x3 equal to 0, x3 is also 0, and given that which means divide by probability of x3 is equal to 0, right? That's how you need to do it. Now this probability is 1 by 2. You can definitely put it, and then finally you will be getting from here, you will be getting x1 x2 equal to 0. But you cannot remove this. Earlier also we haven't removed it, but it so happened that even if you remove or not remove, I mean earlier also what we did, like here, yeah, that is the page. So here like what you did, you are saying that okay, not that is another page, sorry. Yeah, so here what you are saying, you just put the value, but don't remove the information that x3 is 0. So now you want to find out the probability of x1 x2 equal to 0, but keeping in the mind that you know that x3 is 0. But it so happens that we are so lucky that you don't have to keep that in the mind to calculate for x1 x2, because these are independent random variables, right? So this time we don't have to do it because these are independent. But now if you are actually substituting the value of x3 equal to 0 here, you can definitely do it, and then you come up with this, that's fine, but you cannot remove this, that's not allowed. Now these has become independent. Now you do what? You just open this up, right? You just basically say x1 x2 equal to 0 into x3 equal to 0. Now how you can open this up, how you can do the multiplication, because now the things are independent, right? Now you cut this out, now the same thing you are getting, which is 3 by 4, right? Okay, so I hope you understood. Yeah, sorry about the confusion. So actually I have removed this information that x3 is 0 unconsciously, but yeah, you cannot do it. Okay, maybe we can do it more visually using the tree diagram. So let's just see that if we can do it using the tree diagram, right? So what we want to calculate, probability of x1 x2, or maybe let me just say by is equal to 0, given that x3 equal to 0. Okay. So there are three variables, three random variables, x1 x2, this is y, right, and x3. So since these are independent, does not matter you start with x1 x2 or x3, does not matter, right? So let's suppose you start with x1, it can take value 0 or can take value 1. Now currently I have not told you tree diagram in the YouTube, I think, so you might not be that much comfortable, but just see if you can understand this. See, these are taking, x1 is taking with 1 by 2 1 by 2 probability, these two things, right? Now if it is 0, now you talk about x2. Okay, now you talk about, at this level talk about x2, it can take 0 1, given that x1 is 0. Since it does not matter, right, since it does not matter, that's why it is just half probabilities, x2. So this is for x2, like this level is for x2, this level is for x1. Okay, so I'm saying x1 can take value 0 or 1, x2 can take value 0 or 1, this is 0 or 1, with half of probabilities. Now again, x3 can take the value 0 or 1, this level is for x3 by the half of probabilities. Okay, half of probabilities. Now what they've asked is that, what they've asked is basically probability of x1 x2 or x3 being 0, given that x3 is 0, right? Okay, so this is the probability that they've asked. Now what, like how to do this question? What you can do, you can calculate what is the value of y. So this is y, right? I mean using the tree diagram. So what is the value of y here? x1 x2 x3, right? x1 x2 x3, this is x1 into x2 jor x3, right? Which means like this is 0 into 0, 0 jor 0, it will be 0. Like you need to actually calculate all the possible values, right? This is 0 if x3 is 1, if these two are 0, if it is 1, this will be 1. So these are the, okay, am I audible now? Sorry, till what point you have understood? Can anyone quickly tell me what I was talking about? Okay, let me quickly repeat. um, have you understood this method? Have you understood this, that you cannot remove this x3 equal to 0 by just putting it? If you are putting it here, you can definitely put it, but you cannot remove this x3 equal to 0 thing. Okay, okay, you have understood this, right? Cool. So you cannot remove it, and now I was talking about that you can even make a table, and it is given to you that x3 equal to 0. Okay, x3 equal to 0. Basically in the table there are 8 rows, but you can just work with the 4 rows because it is given that x3 equal to 0, right? So you can just work with the 4 rows. Now, what are the possible values of y? It is 0 here. X1 into x2, 0. This is 0. This is 0, jor 0. This is 0. This is 1, jor 0. This is 1, right? Okay. So now they are asking that what is the probability that y is 0? So basically it is 3 out of the 4 possibilities, right? Even though it is reduced domain, you don't worry about it. Or maybe you can just sum all the probabilities here. So you can say this probability, the y equal to 0, this row probability is actually 1 by 2 into 1 by 2 into 1 by 2. Okay. Tell me what is the probability of this row? So basically here you don't need to count this x3 equal to 0 probability. Okay. So basically you will say the probability here that this x3 equal to 0, because it is given to me, I am making use of this information, right? You will say this is 1 by 4 probability, 1 by 4, this is 1 by 4, this is 1 by 4, this is also 1 by 4. Right? I mean every row has equal probability, which is 3 by 4 if you just want to find out what is the probability that y is 0. Okay. So basically that particular tree diagram is not very interesting because it is not giving you any information. But if you want, you can draw the table. Now in this table, I just want to make sure one thing is that don't write the probabilities here like 0, 1 by 2 into 1 by 2 into 1 by 2. See, this x3 equal to 0, this probability is actually 1 because you know that x3 is 0, right? So if you want to find out this probability, this is 1 by 2 into 1 by 2 into 1 because you know that x3 is 0. It is given to you. That's not a probable thing now anymore, right? You know that x3 is 0. So that's why just write 1 here if you're using table. So that's the important point that I want to emphasize here. That now it is not the case that you don't know anymore. You know that what is this, what are the values of x3. X3 is given to you, which is actually 0, which means now the probability of x3 equal to 0 now becomes 1 because it is very much like it is 100% probable. Okay, let me know if you have understood this. Cool. So basically just to summarize what you can do, if they have asked you something like this, some function of this x3 equal to 0, then what you can do, you can use the formula, right? This is method 1. You can use the formula, definitely, that is not an issue. But remember, don't just throw this out. Okay, don't just throw this out. I mean you can put it here because you cannot separate it out because y is a function of x3. You cannot separate it out. You can put the values and then you can separate it out, right? Or maybe you can directly put the value here. That's also fine. But importantly, you don't throw this out, right? That's the thing I wanted to tell you. Also, if you want, you can make a table. That's not an issue. But in the table, whenever you are writing x3, then this probability, don't count this probability as 1 by 2 or something, right? This probability of being x3 is actually 1, right? Whenever you are making a table. So that's very important to understand that if you're making a table, that's not an issue. You write all the possible combinations, but since it is a conditional probability they are asking, so you have to be very conscious. Whatever is given to you, that is known, that is 100% fact for your particular experiment. So that's why don't make this probability as 1 by 2. Yes, Rohit. So Rohit is talking about the normalization and all that we have talked about in the course videos. So you have watched the course videos. Now, now this thing, type of the random variable which are discrete and continuous, this is actually a small topic, which is the probability distribution. I mean, compared to, right? Probability distribution. So let's just do one thing. Let's just do this topic quickly tomorrow in 2 hours of lecture, and then we will be done with the probability. Okay, at least the later part of the probability. Let me know, apart from this, have you understood what is a random variable and how to solve the random variable questions? Are you comfortable with the function of the random variable and these things, right? If some function is given, don't worry about it. Okay, just see that if you can write the PMF of this function, maybe If the conditional is given, then don't include this probability. That's the mistake that most of the students might do. Okay, if the function, if the conditional is given, then don't write this probability. That's all. Okay, so thank you everyone, take care. Sorry, there was some confusion that I did. I hope, but still things are clear. We will make it more clear using some more examples tomorrow. Okay, so just 2 hours of more lecture should be sufficient now. I think we have consumed 2 hours. 2 hours of more lecture. Okay. Thank you everyone. Take care. If you have understood everything, please just comment it out. Just let me know that you have understood everything. Take care. Bye bye.